Welcome to this tutorial on specifying data types when creating NumPy arrays. In NumPy, the dtype parameter gives you control over how your data is stored in memory. This is crucial for optimizing performance and precision in your numerical computations. Throughout this video, you'll learn how to specify data types during array creation and understand why this matters for your projects. There are four main reasons to specify data types explicitly. First, memory efficiency. By choosing the right data type, you can significantly reduce the amount of memory your arrays consume. Second, precision control. Different data types offer different levels of numerical precision, allowing you to balance accuracy with performance. Third, performance. Using optimal data types can make your computations faster because the processor can handle certain types more efficiently. And fourth, type safety. Explicitly specifying types helps prevent unexpected type conversions that could introduce bugs into your code. The basic syntax for specifying a data type is straightforward. You simply add the dtype parameter to any array creation function. For example, when creating an array with the array function, you pass dtype equals a string representing your desired type, such as int32. After creating the array, you can verify its data type by accessing the dtype attribute. This will confirm that your array is storing values as 32-bit integers rather than NumPy's default type. NumPy offers several integer types with different ranges and memory footprints. Int8 stores values from -128 to 127. Uint8, where U stands for unsigned, stores only non-negative values from 0 to 255. Int16 ranges from -32,768 to +32,767. Uint16 goes from 0 to 65,535. Int32 can handle values up to plus or minus 2.1 billion, and Int64 can store values up to plus or minus 9.2 quintillion. The number in each type name indicates how many bits are used to store each value. For decimal numbers, NumPy provides three main floating point types. Float16 is half precision and provides approximately 3 decimal digits of accuracy. It's useful when memory is extremely limited. Float32 is single precision with about 7 decimal digits of accuracy. This is a good balance between memory usage and precision for many applications. Float64 is double precision and offers approximately 15 decimal digits of accuracy. This is NumPy's default floating point type because it provides high precision for scientific computations. Remember, higher precision means more memory usage, but better accuracy in your calculations. The dtype parameter works with all NumPy array creation functions. With the zeros function, you can create an array of 5 zeros as 16-bit integers. Using ones, you can create a 3x3 matrix of ones as 32-bit floats. The arange function accepts dtype to create a sequence as unsigned 8-bit integers. And linspace allows you to specify the data type for evenly spaced values, such as creating 5 values between 0 and 1 as 64-bit floats. This flexibility means you can control data types regardless of which creation function you're using. NumPy accepts multiple formats for specifying the same data type, giving you flexibility in your code. For int32, you can use the string int32, the NumPy type object np.int32, or the shorthand i4, where I stands for integer and 4 represents 4 bytes. For float64, you can use the string float64, or simply pass Python's built-in float type. All these formats produce identical results, so you can choose whichever style is most readable for your project. Let's recap the key points. First, use the dtype parameter to specify data types during array creation. This gives you explicit control over how your data is stored. Second, choose appropriate types to balance memory usage and precision based on your specific needs. Third, familiarize yourself with common types like int32, int64, float32, and float64. These cover most use cases in numerical computing. And finally, remember that the dtype parameter works with all array creation functions in NumPy, making it a universal tool for type control. With this knowledge, you can now create more efficient and precise NumPy arrays in your projects.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.